So some other types of variation that we could have are listed here. You may have run across these before in Algebra 1 or maybe in a science class, but you'll see them often when we start to model things, like I said, in science and throughout math classes. So direct variation, the words that you'll see with that is something like y varies directly as x, or y is directly proportional to x. The key thing on this is this equation. Let's see if I can circle it without making a huge mess. Y equals kx. Okay, so this means it is a line, and k is the slope of it, and it's a line that goes through the origin. Okay, and what it means is as one thing goes up, the other thing goes up. So an example of direct variation would be like how much you get paid based on how many hours you work. If you work 0 hours, you get $0, but then you get you have a constant, a variation, so how much you get paid per hour. So we also have direct variation as an nth power, and the way you would see this in a problem is it would say y varies directly as the third power of x or the square of x or something. You might also see it as y is directly proportional to the nth power of x, and the equation for this is y equals kx to the n. Inverse variation, y varies inversely as x, or y is inversely proportional to x. And you would see that equation as y equals k divided by x. Inverse variation means as the x value goes up, the y value goes down. Okay, where direct variation, they go up together. If x goes up, the more hours you work, the more you get paid. Inverse variation goes the other way. Combined variation might have both direct and inverse variation. So it might say z equals kx over y. That's where you have more than two variables. And then joint variation is, again, more than two variables. You'd see something like z varies jointly as x and y, or z is jointly proportional. And the equation for that is z equals kxy for some value k. So in all of these, k is some sort of constant that we're going to have to figure out. So I'll show you how these work. Mathematically, they're not difficult. You just have to figure out which one of these you're using. So the simple interest on an investment is directly proportional to the amount of the investment. Okay, so we can write an equation just based on that. So the simple interest, I'm going to call it I, is directly proportional. That means there's some constant to the amount of the investment. I'm going to call that the principal. That's how much we invested. Okay, so that's my equation. I equals k times p. Now, we don't know what k is. We want to figure it out. So, for instance, an investment of $2,500 will earn $187.50 after 1 year. So we're going to plug that in. So $187.50 is my interest. I don't know what k is, but I know that my principal, the amount that I invested, was $2,500. And now I can solve that for k. I'm just going to divide both sides by 2,500. And we find that k is 0.075. So we take that back over here to our model. The interest that we're going to earn in a year is going to be 0.075 times our principal. Okay, and that is our math model. So when you're trying to find these math models, start with whatever equation, plug in the values they give you to find your constant, and then go back and put that constant, that k, in the problem. All right, let's check out another one. Neglecting air resistance, the distance s an object falls varies directly as the square of the duration t. We're going to stop right there. The distance s an object falls varies directly, so equals k times something, as the square of the duration of the fall. So that was an equal sign. So varies directly as the square of time. So s equals kt squared. All right, so that's our model. We want to figure out what this k is, what that constant is. So to do that, we're going to use these numbers. An object falls a distance of 144 feet, so that's our s, 144 feet. We don't know k, but we do know that our time is 3. Okay, so we get 144 equals 9K. Divide by 9, and we find that K is 16. So then we go back over here and plug in that 16. So the distance that it falls is going to be equal to 16t squared. And now we can use that model to find any distance for a falling object. All right, we'll do one more on this video, and then we'll take a little break. A company has found that demand for its product varies inversely as the price of the product. So we're going to stop right there. So demand varies inversely. That's K over something. K over the price. We'll just call that P. Okay. Now, we don't know what K is. We need to figure that out. So when the price is $2.75, that was our price. The demand is 600. Wow, that was really terrible. Let's try again. All right, we're going to solve that for K, so I'm just going to multiply both sides by 2.75, and that gives me 1650. So the model, come back over here, the model is demand is 1650 divided by P. There's our model. That's not the end of this problem. It now says approximate demand when the price is $3.25. So we're going to use this equation we just created. Approximate demand when the price is $3.25. So we plug into that model, and we're just going to grab a calculator and divide, and it's going to be 508 units. They didn't tell us what we were selling, so just units. We'll see an example of some other types of variation in the next video.